good day guys. Today I will present the Design Laboratory 7 Internet of Things. So first, let's talk about the problem. So the problem is that when you are in a car outside your house and you want to open the gate, you need to get out of the car to open the gate, which can add more hassle to you, as well as closing the gate after you go out to your house when you are in a car. So if you can close and open the gate digitally, this will save a little bit of work. However, if you are doing it long time, it will add up. So the other problem that I identify is the street light, which is sometimes not open when it's dark outside, because it is operated manually. So having a street light that automatically turns on when it turns dark can greatly help in the community. So this is my sketch proposed design solution. So as you can see, the gate must be a gate that can be controlled, and it is represented by a servo motor, which is also can be controlled by a push button, an LDR on street light to detect the luminosity, and an LED light to indicate that it is the street light. So this is my circuit diagram, and as you can see, I use the Arduino Uno because there are no Wi-Fi module in the Tinkercad, but in the actual device I use a Wi-Fi module. The components that I use are LDR, a 10k ohm resistor, an LED, a push button, and a servo motor, and a couple of jumper wires. So let's go to the app. So this is what my app looks like in DESIGN-Lab 7, and let's discuss the component I put in this app. So first, I put a vertical slider which dictates the position of the servo, and I connected it to the virtual pin, which is V1, and then I put a gauge that indicates the servo, and it will present what value the servo is. And I also connected it to the virtual pin. So next is the light. I put a button for the light, and its output pin is the digital pin number 4. So I also put a indication of the LDR value. So that is all for my app. So let's go to the Arduino code. So this is my Arduino code, and in my Arduino code I first initialize all the components needed, which is the button, the LED, and the temporary variable for button pin. I also included the LDR pin. I defined the blink print serial and include the ESP8266, which is the Wi-Fi module. I also include the servo. So in this character, I first put the token that the blink up send, and the SSID, which is my Wi-Fi, and the password of my Wi-Fi. So next in the setup, I let the LED be the output, and let the button pin and the LDR pin as the input. So I float the LDR status and attach the servo to the D1, which is the digital pin 1, and initialize the value of servo, which is 0. here I set that if the button pin is pressed, the servo will move to a certain degree, or if not, it will go back to its initial position. And for the LDR status, if it is less than 100, the LED will turn on, and if it is greater than 100, the LED will turn off. So in my loop, I let the blink up right whatever is clicked there, and the Wi-Fi module will respond. So that is all for my code. So first is the gate, which is the servo motor, that and you can control it using a push button when you are inside the house. So this is how to control the servo using push button, and you can also control it in your phone if you are outside the house. For the LDR, when there is no light, the street light will turn on, which is the LED, and when there is light, the LED will turn off. So you can also control it using the phone. And that's all for my Laboratory 7. My learning experience in Design Laboratory 7, which is the last laboratory. So I learned a lot on how to operate ASP8266, which is the Wi-Fi module. I also learned to create an app that can control Arduino components. So overall, this subject helps me to learn a lot of things, especially in coding. This subject helps us to enhance our creativity, which is very important aspect in engineering or as an engineer. So that is all for my laboratory. Thank you.